Hello everyone, welcome to the lecture series of Control System 1. In this video, we are going to learn the summary of block diagram rules. There are various rules to reduce a block diagram to make it into a simplest control system where we can analyze by using only one block. That one block will consist of the reduced transfer function of that particular system. Let us see all these rules in detail. The first rule is series or cascade rule. If two blocks, let's say G1 and G2, are connected in series, then their equivalent block can be drawn by multiplying their forward path transfer functions together. So here G1 and G2 are multiplied together. RS is our reference input, CS is controlled output. Rule number 2 for parallel. When two blocks G1 and G2 are connected in parallel, the meaning of parallel is they are reaching to one summing point with the same signs. That is nothing but they are in parallel combination to each other. Therefore, their equivalent block will be written as G1 plus minus G2. This is parallel rule. Rule 3, which is nothing but a loop rule, or which is also called as a closed loop rule, where we are able to see here a closed loop. In a previous video, we had derived its equivalent transfer function, that is G1 upon 1 plus G1 into H1. So in this particular image, we are able to see here it is plus minus, but mistakenly here also it is written plus minus. But we know the derivation. If the feedback is positive, then the closed loop transfer function denominator side gives us negative sign. So let us take, in this case there is positive feedback, so the equation will be given as G1 upon 1 minus G1 into H1. Whereas if the feedback will be negative, then this particular equation will be given as G1 upon 1 plus G1 into H1. So this is a loop rule. Let us go for the fourth rule, that is associative law. If two summing blocks are connected in this fashion, then their position can be exchanged, and that exchanged position will not make any difference to the transfer function of the control system. Hence, we can able to exchange these two summing points as shown here. Let's move toward the fifth rule, that is moving a summing point before a block. Let us see, here is a summing point. This summing point has two input. One input is from X and another input is from R of S through a forward path block, that is G. Now if we have to move this particular summing point to or before a block, then we have to make changes in that diagram as given here. We have to add a block 1 upon G in the path of X. This particular addition of a block in a path X 1 upon G will show us or will give us an equivalent block diagram as here. So when moving a block, while moving a summing point before a block, we have to add reciprocal of the block which is in forward path into the path of X. Let us see next rule, moving a summing point after the block. if we have to move summing point after the block, then we have to add a block as it is in the path of x, which is in our forward path. So here we are adding a block g which was there in the forward path before. So this will give us the equivalent diagram as it was previously. Next, move a takeoff point before a block. See friends, this is a takeoff point from where we can take feedback from output to input. Now if we have to move this takeoff point before a block, then we have to add a block as it is in the path of x, which will give us a equivalent circuit as it was previously. Here, moving a takeoff point after the block. Now this takeoff point we have to move after the block. So here we have to make a change. We have to add reciprocal of the forward path block into the path of x. This will give us an equivalent block diagram as it was previously. So these four rules are very related to each other. To remember these rules, we can remember any of the case. So as I remember these four rules in a fashion of moving something after the block. So let's say we are moving summing point after a block and we are moving takeoff point after the block. If we are remembering these two rules, we will be naturally able to remember their opposite natures, that is before the block. Let us take for summing point. See friends, for summing point moving after the block, for summing point movement after the block, we have to add the forward path block as it is. We have to add forward path block as it is. Whereas moving takeoff point after the block, we have to add reciprocal of the block in the path of x. So if we are remembering these two, it is very easy to remember the remaining rules, that is rule number 5 and rule number 7. Let us move towards the next rules. These two rules are very critical rules and which are very rarely used in our block diagram reduction techniques, but still we will learn that. In this particular rule, we have to move takeoff point after a summing point. We have to move takeoff point after a summing point. To move takeoff point after a summing point, we have to add a summing block. We have to add a summing block in the path of x. In the path of x, where we will be able to get the same equivalent equation. But here we have to see the function y which is inputted to this summing block is in negative positive fashion. So the overall input of this particular z block will be r, this is r plus minus y. So plus minus y is this plus minus y come here, plus minus y will come from this path, and this y will also go to the summing block in negative positive fashion in this way. So combinedly we will get positive negative and negative positive, which will cancel out these two terms y. Finally we will get only r. So this is the rule for moving takeoff point after a summing point. Exactly in opposite way, moving takeoff point before a summing point. Let us see, we have to move a takeoff point before a summing point. We have to add a summing point in the path of z by adding plus minus sign from the input y. So the final output of this particular block diagram will remain equivalent in both the cases. Will remain equivalent in both the cases. So these are the two critical rules which are used for the position change between summing point and takeoff point. These are very rarely used rules.